to.
I will. I will. That'd be fun.
I don't know if I would trust Nate teaching class. Miriam, maybe.
What about me?
You didn't volunteer. I'm only talking about them because they both said yes. I think between Miriam and Lacey, that'd be a pretty good duo. So at the top of your notes, there's a reminder of how we find probability. I will accept volunteers today to come up and walk through these different types of probability problems. So we're going to start by taking a few minutes to look the worksheet over on our own, and then I will take volunteers that have to have the problem done on their paper before you could come do it on the board. So this homework is due today. And the other reminder I need to say again, after I turn my music off because I've been jamming all morning, is that if you have revisions to the test, the equations, inequalities, and circles test, please get those in. I've delayed a long time posting those grades because I've had literally 4 revisions come in. That's it. So if you did your revision, but you're like, wait, did I turn that in? You might want to double check if it is still in your binder. You didn't turn it in, right? Which is not good. We need it turned in. We will go over the day 2 and 3s worksheets of that review stuff tomorrow and Monday for the OST review stuff. Also on Monday, we will, in Foundations, take the math practice test. And then, next week, we will take the math OSTs. I don't believe we'll have math class on those days. Go ahead, I did not see what you were trying to do. The next stuff we'll do in math class after OSTs is go back and revisit that house design challenge. So if you don't still have that worksheet, we'll need to start that over. Eventually. But it's more it's not like I have to turn it in, it's just we want to do it. It's a fun thing to do. Yeah, and I don't know where we'll go after that. Oh, we might do a casino day. I don't know if I can actually do that or not. I got to talk about what I'm allowed to do with you guys. But analyzing the different probabilities of different games. So by casino, I don't mean we're going to play on the roulette wheel. I mean we're going to look at different games, like card games that you guys play, and look at the different probabilities. Hey, did I say, hey, make suggestions to me? I did not hear that come out of my mouth. I don't know if I'm like the Looney Tunes where there's a sign on a stick that says help me or whatever. All right, Miriam. Now what I might do is switch my camera if we're going to do this so that we can see you at the board.
Luckily, I'm not. Oh. Okay, so are you asking
if you want to do this one.
Should I do the next one? I'm pretty sure I know what you mean.
Here, let me see it for. Hold on. I don't want you doing it until we make sure we're good. Yes.
Okay. What? So, basically, in this question, you spin the spinner shown below once. The spinner has 4 equal sectors, colored pink, purple, blue, and green. What is P? Blue. Okay, so basically the circle is as they say, divided into 4 sectors. And what they're asking is what this sector is out of all of these.
I like that you're coloring in blue with red.
Yeah. Okay, so because it's out of 4, this sector would be 1/4. Yes. Or if you turn it to a decimal, it'd be 0.4. No. Okay.
That would be 25 hundredths.
So because Nate, I'm going to say, did that on purpose.
I know.
I'm trying to save you, buddy. Let's talk about, again, how we convert from fraction to decimal. So very good, Miriam. 1/4 or 0.25. But yeah, there is that temptation, guys, that when we go to convert to decimals that we do this wrong. So remember, to convert to a decimal, what fraction are we actually stopping at on the way? On the way to a decimal, we actually turn into a different fraction first. What is that fraction?
2500.
Whatever fraction gets us to a 10, or a 100, or a 1000, or whatever on bottom is a power of 10, right? Because those are our decimal places. Tenths, hundredths, thousandths. So if we're still having a little bit of rockiness with getting to the decimal form, first off, you don't have to go to the decimal form. You can just use the fraction form 1/4. But if you want to go to decimal form, we can do times 25 on top and bottom, and we get to 0.25. Any questions on that one? Like I said, in probability we wouldn't say this, but if you want to talk about the chance, which is actually adjacent to probability, this would be 25%, but we don't really talk about that in probability. We keep it between 0 and 1, fraction or decimal. Wait, what do you have for the denominator? Let me double check that.
I just did.
Yep, perfect.
Yeah.
And then you just reduced it to the
Yeah.
left as opposed to going to the right.
Yeah,
That's
because
fine.
I wrote the 3/5 first.
Ah. So I did not print the marbles on your paper because, well, on a black and white print, as you see with the spinner,
They look very
unless they're labeled
Yeah.
blue, red, green, they're kind of hard to tell the difference. So go ahead, Lisa.
Okay, so the question is: you randomly draw a marble out of a bag that contains 20 total marbles. 12 of the marbles in the bag are blue. So if 12 marbles out of 20 marbles are blue,
You're
then
talking to them, not me.
if 12 marbles out of 20 total marbles are blue, then it could be 12, 20.
Now, the fun thing is in con, you can just type that in.
Yeah,
It does not make you reduce, because that's a fine way to talk about probability. 12 blue marbles out of 20 total marbles. But if Lacey wants to reduce, go ahead.
Since it's 20, you could easily reduce to 6/10 or 3/5.
So actually that second fraction that she got right there, go ahead and box out that 6/10 for me. That is the really nice one to go to a decimal from. Because then our decimal would be
0.6.
nice.
Yep.
But I was pointing at Lacey. But yeah,
Yeah.
go ahead and write that up there
Yeah.
too. So all of those answers, and even more, but all of those answers will be accepted by con. So guys, that's why I only extended your homework one extra day, because you should be able to get this done today, and if you can't, come see me. Right? You need to use your AO and your extensions. I'm available second AO. I know I'm not first AO, but I'm also available all of extensions, and that's why I don't have other kids in here. Right? My room is math lab. Nate? You gotta come show it to me. Again, I did not print the blue marbles. You can keep going. If you're sitting here I don't want to wait for this to happen, you can keep going. Yes, and then as long as you can reduce it. It's alright if you can't. You can go ahead and take it as far as you can, as long as you can talk about it. Can you talk about it? You can change colors down here. But I think we're still talking about blue, right? So we can keep writing in blue if we want.
So you have to find the total number of marbles, which
No, wait, why do we have to do that, Nate?
because it's out of
The out of, the denominator, is always
the total. number.
yes. So guys, remember, the denominator is always your total. If they don't give you the total, the first thing Nate said, but I want to make sure you guys heard it, is we have to find our total. So how did you find your total, Nate?
I added the total.
Go ahead and underline those numbers. The 3,
I added
the 3, the 4, and the 5. We put them all together because that's all of our marbles.
That equals
I don't know what you did to break the pen, Nate.
It's 12. And then you have 3 blue marbles, so the other.
By the way, guys, if the ink is turned on, you can actually just use your finger to write with, and your flat hand erases.
Oh, yeah.
Making sure. Here, I'll take that. So 3/12, and you can type that in on Khan. What would be a math class if we didn't use some random cards? If I go to reduce 3/12, Isaiah, what could I reduce the top and bottom by? Like, what could I divide by? What are both 3 and 12 divisible by? Yeah, if we divide by 3 on top and bottom, we get 1/4. And we already saw on a previous slide, if you want to go to the decimal, I don't really like decimals in probability, but some people really like decimals. When I was a kid, I thought decimals were the hot thing. And then I got older and I was like, fractions are pretty cool. But get off my high horse about fractions versus decimals, 0.25, right? 25 hundredths. And that's one that we just want to start to memorize. That 1/4, and this really comes from money. 1/4 is 25 hundredths, a quarter of $1, a quarter of 100. You roll a 6-sided die, not in the casino. You're not at the craps table, right? Because I teach middle school and I don't teach gambling. Wink, wink, nudge, nudge. If you, guys, I will be 100% honest with you. I had no idea how to play the game craps, which some of you are like, there's a game called craps? It does not involve poop. It's all about dice rolling, and you bet on the outcomes. But if we only roll 1 die, as opposed to dice, a lot of us are used to 2 dice, like Monopoly and all those games. We'll talk about 2 dice situations. But if I roll 1 die, Madeline, what are my outcomes possible? My possible outcomes. Yeah, I could get a 1, 2, 3, 4, 5, or 6. And I'm going to be lazy and just use the numbers. But we know on the dice, you would have the dots on there, right? So when we ask for probability of not 5, what's our chance of not 5? Ooh, give me the fraction first. Ugh! Do you just want to hurt my feelings? If we get rid of the 5 as an option, the favorable, right? The things that we want is everything that's not a 5. So our probability of not a 5 is 5 out of 6. Which then, if we convert to a decimal, 0.83, and I think it's kind of messy. There's some stuff out here, I'm pretty sure. Yeah, so be careful with decimals. A lot of them are messy. 5/6 is better. Guys, here, this is not my opinion. The fraction is more accurate. The decimal gets rounded, so the fraction is better. It's not my opinion. This is a fact. The fraction is better here. Natalie?
I just want to do the next.
Sweet. Let me get to it. Guys, I dig this a lot. So you're like, ooh, I got it. I can do this, man. Do you want to come up?
Ooh, but also...
Bruce!
Yeah, I want to do glasses.
Is this? I'm doing.
Yeah, let me check.
That one is the answer. Oh, thank you.
Which one is the answer?
That one.
Yes, yeah, and then we can reduce it, right? Or we could make it bigger.
I can't read.
Sure, yeah, take it as far as you know, and then we can go from there.
Okay. So you randomly draw a marble, or no.
Bruce!
Bruce is gonna call one of his contacts at random. He has 25 total contacts. 20 of those contacts are from his neighborhood. So since there's 25 and then 20 are from his neighborhood, there's 5 left over, so it'd be 5 over 25.
Natalie, how'd you figure out that 5? It's not in the problem.
Because he has 25 and then there's 20 of those are from his neighborhood.
So you
then there's-
did...
He sounds like an awful neighbor. Math.
You did subtraction, right? So Natalie figured out the 5 by doing subtraction, right? So sometimes we have to do a little bit of math. The 5 wasn't given to us, but it kind of was, right? Sort of. That's where Natalie's like, I don't know. What do you mean, what did I do? Like, she just, like, thought about it, right? Thank you very much. Who wants to help take this to the decimal? Victor, you want to... Ooh, Drew? You don't have to, but you can if you want.
Make it decimal. 25 to 100 times 4.
Yeah, so hold on. 25, now you said it a little bit weird, but I know exactly what you meant. 25 turns into 100 by doing multiplication by 4. I'm with you. So what's this become? So then our decimal is? Yeah, 0.20, which is fine. You can say that, but this 0 doesn't really matter. Just like over here, really, we could get rid of those and make this just 2/10. Right? 20 hundredths. It's 0.2. Yeah, 5 25ths. This is right. You can leave it there. You don't have to do anything else with it. But if I reduce that, if I go the other way, instead of getting bigger, what can 5 and 25 both divide by? 5. And if we divide them both by 5, 1/5 is also the same answer. These are the same. Well, they're not, but they are. But they're not, but they are.
They're twins, but they're not identical twins.
Yeah, I
They're
dig it.
fraternal twins.
They're
I couldn't help
fraternal
but think
twins.
about Batman this whole
Or
problem.
step.
That makes no sense.
So now, these problems, people like to overcomplicate these problems, and I don't know why, because I'm just like a visual kind of person. But guys, this is just saying that at one of the festivals, he sold 5 feathers. At the next festival, he sold 6. At the next one, he sold 1. Right? This is just a list of data. Whatever, my brain is trying to do a lot of things. I got a lot of numbers. There's a head on my floor. I don't know quite what's going on. Like,
It's for our play.
Lacey just walks into school today. She's like, nothing to see here.
Oh my
Just a
god.
decapitated
If
head.
she rode the bus ride would be stupid.
Right? So, I appreciate your hand being up, but I'm trying to incorporate more people. Victor, if we think about based on this data, right, table of data, what is the probability that Patsy sells fewer than 5 feathers? And on your worksheet, I kind of rewrote this, and I actually said less than, right, because those are synonyms. Fewer than, less than, all those words that are exchangeable. So we could write this. Please, on your paper, take a second to actually write this. We would write that as P parenthesis. You could either use the symbol, or you could write the words less than. Sorry, that looks weird.
What?
P parentheses less than 5. You could also write it like that. Victor, what's our chance of selling less than 5 feathers? Well, what's our denominator? Let's talk about that first. 8, because they tell us 8 total festivals. And then how many were less than 5? Yeah, sweet. So 6 over 8, which, what could I divide 6 and 8? Oh, well, they're both even. So, hold on. Voice from above. Can you? You probably can. I know, right? Victor? Yeah, not percent, though. We're going to go ahead and leave it as the decimal. You went one step just too far. 0.75. Right, you're right. It is 75%, but in probability, we don't want to talk about percent. Questions, please.
Okay, I mean, I know that it's not really a question. I just wanted to point out on the back side, it says, like, I don't, like, how we don't like percentages, but then Harry and Larry.
Well, they're just saying which one's more probable. You can turn that into a decimal.
Yeah.
It's easier to solve for.
So this is kind of the transition from probability to all things chance.
Yeah.
So
A chance per-
So, this is where, Like, I really do, guys, I'm just going to be honest, I really do struggle to teach certain things because it's just one of those, like, abstract, like, we have this rule, but it doesn't really have to be firmly applied. And it's sort of like when, you know, if you've ever been to the pool and they're like, no running on the pool deck, but then somebody runs to dive in and they're like, whatever. Like, I don't know. I used to be a lifeguard, so that's sort of what's in my head. But, like, yeah, a long time ago, like another life ago. No, but I mean, like 15 years ago. So, percents get used when we talk about chance events. But when somebody asks you the probability of something, we're more normally trying to discuss something out of something, right? Like a ratio. So that's why probability tries to stick to not the percent. Because as soon as you go to the percent, what is percent out of? 100. And guys, did Patsy go to 100 festivals? No. Not even close. So that's where percent kind of murkies the waters. Of like, we can use the percent, but it almost works backwards. It almost makes it almost tells us less.
Yeah, I just thought it was funny because on the back they used percent.
Yeah, and I knew one of you guys were going to point that out. You just got there first. Nate, question?
Oh no.
Sorry, somebody's hand up?
Can I also say a thing for the multiple choice questions that people have on time?
Sure.
It's never going to be the exact one because, like,
Yeah.
with probability, there's no chance that it's going to be exact.
Yeah, that's the other issue with percent and sometimes decimals. They're just not exact.
Those are already trapdoors.
Yeah. I don't know if I would call them trap doors. They're like kind of slippery.
Well, they're never going to be right. Is it slippery?
Yeah, never 100%
Well, yeah.
right.
But when
See what I
you
did
have
there?
that-
Madeline. Have you done one already? Okay, well then sure. Yeah. Do you want to come up? Well, oh, the next one. Okay, anyone want to volunteer for this that hasn't done a problem yet?
I definitely haven't done a problem yet. Did you know that?
I guarantee you have. I like your glasses, by the way.
Ratchet.
In case I... Whoa! Calm down. First off, a ratchet is one of my favorite tools, so when kids started saying that, I got very upset that that word was being used as a negative thing, because I love my ratchet, which is a tool that does this.
I thought it was a positive thing.
Yeah, being
No, I think ratchet means like...
I thought
Ratchet is
like swag.
No. Why are we doing this?
I don't know, but I thought it was like a good thing.
Ratchet is... Ooh, wait, maybe. Wait, what? Since when?
I always thought it was.
Ratchet is a slang term that can mean exciting or excellent, often used as a term of empowerment. I thought ratchet... Wait, hold on. Some may use ratchet for when they're feeling bad in some ways. The term previously used as an insult. Now they're... I don't know. Now they're trying to, like, take it back, I guess. I don't know. So, there you go. There's your Hudson is easily distracted moment of class. Would anyone like... Nate, stop. We gotta have class. If you're gonna do this one more time, you can just go chill in the hall. Okay? Like, it was funny, but we need to move on. And I see you trying to do it again, but then it's not funny anymore. Moving on. Todd is training for a marathon, and this creeps me out because Todd is actually a friend of mine that runs every single day. So I'm a little worried that Khan Academy is following my life. The following histogram... Oh, histogram. So, wait, what's a histogram? Let's pause for a second. What? This is not Instagram. This is histogram. What is a histogram, Mia? What specifically about the graph? You're right. Charlie? Shows things that have numbers on it. Love it. We can be more accurate.
It's not spaced out.
Well, I don't know. Oh, there aren't gaps. I agree, there are no gaps here.
Yeah, that's all.
A histogram is characterized by having equal... You might want to write this down. Equal sized... And guys, I don't know why... Well, I do know why we use this word. I just wouldn't have necessarily chosen it. Equally sized bins. And what we mean by equally sized bins is this right here is a bin. So the results get broken up and kind of placed into these bins by how many fell between 0 and 5. How many fell between 5 and 10? How many fell between 10 and 15? But this creates kind of a problem. Where's 5 go? Where's 5 go? If I got a result of 5, right, like what is the label there? Number of kilometers. 5 kilometers. Would that go in here and here? You have to make the choice when you build the histogram. So if you put your 5 in here, then 10 goes in here, 15 goes in here, 20 goes in here. And because our graph stops at 20, that's the choice we would probably make. Because otherwise, think about the other option. If 5 went up here, 10 went up into there, 15 went up into this bin, and 20 has nowhere to go because we didn't give it a bin, this would be bad. Right? So when you look at a histogram, you can kind of think about where the cut numbers go because of how it's built, or it's going to tell you, right? Or the problem is going to tell you how it was set up. So based on this data, what is a reasonable estimate for the probability that Todd runs? Notice how they do this. They're not asking you right about 15. They give you 15 and they let you play off it and say go above it. Right? So we're looking at this bin, which is above 15. How many days were above 15? 5. You look at the height of your stack, your bin, your whatever you call it. And guys, this axis is always actually going to be your frequency, or like how many, right? So here we're talking about days, but it might not be days, but it's always how many. So this has 5 in it. 5 out of? Yeah, I got to add them all up. So 5, 3, 3, 2. So 13. Ooh, I don't think that's going to be a nice decimal.
It's not, but it ends and you don't have to round up, so it's 0.38.
So it's about 0.38. And then on con, if it gives you this as multiple choice, you're finding whatever's closest to that. Natalie? Question?
Does the squiggly lines mean like rough?
Yeah, this is approximate. Thank you so much for asking. Because if I don't say it, please do that. If I don't say something, please ask.
Anytime, Rusty.
When did we become besties? I didn't get a bracelet. Don't we have to make friendship bracelets if we're going to be besties?
No, that's not.
That's not how it works anymore? Is there like something on like on Facebook? You guys don't use Facebook anymore, I know, but it used to be like in relationship.
But I haven't used it.
I've never used
Yeah, and every time I bring up Facebook, kids are like, Facebook? Drew?
Facebook is for memes about.
You want to do the... Oh, wait. I think Madeline had asked and I told her yes. So you could do the next one. Look how Drew's like, dang it.
Can I do the like Tina?
Oh, you want a pen, don't you?
Yeah, wait.
What?
Is that right?
You don't want to just be like super confident?
I'm confident enough to teach 8th grade math.
I have to do some math. Where did 27 come from?
I added those.
3 plus 5 plus 19. Makes sense to me. As long as that's what it adds up to, I gotta check that math. Okay, sweet. Let's do it. Oh, you know how to erase the rectangle with the paintbrush. Now here's the quick way. Hit that and then hit OK.
So I did the Tina, Theo, and Toad.
I think Drew, you wanted Steven, right?
Even Steven. I think so.
Here, let's do it like this. So, well, Madeline's gonna do this one, then we'll figure out who's doing the next ones.
Okay, so the winter clothing drive has received donations of 5 coats, 23 shirts of gloves, 19 scarves, and 3 hats. So we want to figure out probability that the next donation is not a pair of gloves. So we need to add all these up, which is 50. And then and you need to add up the numbers that aren't the gloves.
Oh, well, just hit cancel. That was you, not me.
I didn't touch anything.
Yeah, you had to
I
have.
didn't touch anything.
It's this
Your
thing
fault.
down here. You hit that.
I didn't
That saves it. See, look.
Did he hit it?
Well, I didn't hit it.
Well, okay,
No, wait. So exactly what I asked when she came up. The 27.
I'm so mad.
The 27's not given to you. Guys, you have to think a little bit. Not gloves. Add everything else up. I know you said this, but some people are like just glazed over and like just laughing at me. So guys, you got to add up everything not gloves. Madeline also added up everything. Then, what can we do with 27 over 50?
turn it into a decimal.
Yeah, so what fraction can we turn it into first? Miriam's got her hand up. I think she might know.
50 would be times 2, so over 100, so then you times 27 by 2.
So what do we get?
Oh, I didn't do that part.
Oh, come on.
I just did the
27 times 2? 54.
54.
So
Yeah, that's
54 over 100.
what I said. Yeah.
Whoa, so did Victor. I'm just playing favorites here. It's okay. Or I didn't say that.
Okay, and the decimal would be 0.54.
Absolutely. Now do me a favor and maybe write those things with equal signs and whatever. But because she's up on the screen, I know it's a little weird and we run out of space and stuff like that. Any questions up to this point?
Your whole hand. Your whole hand.
I want the
Any questions up to this point?
so small. I want the little one.
Any questions up to this point?
Oh, also, when you guys were saying I forgot the line, that wouldn't be right anyway.
Yeah, it would be because 50 wouldn't be over 27.
Those are just working numbers of hers, right? She's just working with them, so she's just jotting them down and going to use them later.
Are you paying the working numbers now?
No, definitely not. They're going to unionize pretty soon.
Done.
Look, you took it there. Drew, did you want to do the Stephen Red Books problem? You said no? Okay. Mia, would you like to do the Stephen problem? No. Martin? No. You guys have done stuff. Lily?
I actually haven't solved it yet. But I'll do it. I mean,
Wait, can I try to solve it?
Let's do another couple minutes on our own. Seems like we're not ready for Stephen yet.
Even Steven. It's 7.
And then Harry and Larry, we should probably not take them to dinner. But look at Harry and Larry.
Ooh,
And then Tina and Theo and Tony.
why did it all start with T?
Sometimes parents do that as like a thing.
Yeah, my parents did that with us.
Did what?
I don't know why. But they started our names with the same letter, like Michelle and Miriam.
Alright, so I know like there's all these theories about what the vaccine does to people, and I'm starting to wonder if my vaccine made what I think I said turn into something else. Because what I thought I said was try these problems on your own, and what I think you heard was sit and talk with each other. That's it. Really? It's okay. I know my tongue is split like a serpent now, so that that was side effect number 1, but maybe now it's okay. All jokes aside, try these 3 problems. It makes me nervous when I start calling on people and no one has any confidence with it, so try this on your own. Oh, did I not get that copied up here? Ooh, I need to take a moment anyways. So yeah. Oh,
It just tells
who's
you the problem.
sorry? I forgot to paste the question in there. So for Harry and Larry, it is. Oh, and that's the one I didn't put on. That's why, because I didn't get it on this slide presentation and I goofed it up. It's who's more likely to stain their shirt. Really, like we could order them of like who's. We're really just comparing them.
Can I solve for that one?
Give me a second. I'm trying to get it up here.
I want to do it.
Guys, I'm using cards, so everyone can stop asking me because I'm using cards. Everyone can stop asking me because I'm using cards. I can't believe that's what ratchet means.
What is the question on Harry and Larry?
essentially just compare their probabilities and determine who's more likely to be messy.
Okay. I know. Can we do
Your name ends
can we
with
just do the
Mary.
rest of it? If we have time. Yeah.
Man, I also forgot to put Steven on here.
It's Stefan.
Steph, okay.
Person for the Harry Lane.
Oh, you're right, because it was short. It was short for Stephanopoulos.
What?
Yeah, Stefan was short for Stephanopoulos.
No, my cousin's name is Stefan. It is not Stephanopoulos.
But this Stefan,
No, it's gotta be Stefan from
And Mr. Hudson, I have one for the Harry and Larry problem. Your name ends with Airy.
maybe they always spill dairy. Maybe it's because they can't carry.
That's true.
The situation seems quite precarious. Alright, I'm out of options.
How do you spell precarious?
I'm not sure.
Were you asking why he was just taking everything with
Mia? You want to do this one? I'll hand it over. I will check it. No, it looks good to me. So I was reading back and forth. That's why my head was moving. Alright, Mia's going to talk about Stefan and his reading.
Okay, so you would add them all up together and they would be at 49.
Hey, by the way, I really appreciate that when your classmates are at the board, you guys all simmer down and, like, respect that. Like, I really do appreciate that. So good job with that.
And then they're asking for the material.
Yeah, dig it. I love what Mia did. Because adding up the total is kind of like the first thing we're going to do anyways, she just did the denominator. Write it down, put it underline, just do the denominator. Then we can kind of go back and like look at what we're actually trying to answer. Magazine. Right? So that's 20, and there we go. Harry and Larry. Ooh, dangerous. Nate, would you like to come talk about Harry and Larry? You not done with that one yet?
Yeah.
So essentially what we're going to talk about is how we can compare those two probabilities with each other. We could either turn the percent back into a fraction or a decimal, or we could turn fraction or decimal into a percent. Either way, we want to compare them. So you skip in for now? Yeah. And Stella? Yay? Want to come up? Show us what you would do. Now, guys, remember, there's like always a bunch of ways to solve these problems. What would you do to compare these? Yep, absolutely. So show us how you got there, or talk us through your thought process. Or if you used the calculator, I mean, I guess you can say that. But, well, then I will help you when needed.
Okay.
Numbers!
Yay!
Good job.
This is a fraction.
Go ahead and copy it down.
Oh, okay.
I said I'm going to help you. Don't worry, copy it down.
Okay.
You suck at whispering.
What?
Then put an equal. Do you want my help or not?
Yes.
Put an equal sign next to the 1/5. Ask the class. Okay. Hey, here's the secret of being a teacher. When you don't know the answer, just ask the kids.
What is it?
It's a number. Wait, no. Can I help you? Can I
Ask,
help you?
ask what fraction could happen in between.
What he said.
But they can't hear me because I'm whispering.
Not very well.
No, what are you talking about? I can't hear you. You're talking to yourself.
Ask them what fraction goes in between.
What fraction goes in between?
Oh.
Oh.
I used the calculator.
Oh, 15 over 100. Not that one. 20 over 100.
Dang it! That's what I thought.
Good job.
Ask them how they got there.
How'd you get
I
there?
don't know.
A calculator.
Thanks.
Con
I know that we're having a really good time, but what Lacey just said is really, really good. So I'm gonna like talk louder for a second. So Lacey said the first thing we can get to is 2/10. And guys, that is the true secret of being a teacher. If you don't know what to do, just ask the kids. And then and dance. That's the other secret. We can just put a 0 on both of them. That turns it into 20 hundredths. So it turns into 20%, which Stella already had when she walked up because she used her calculator to get there. Which if you have a calculator, sweet, use it.
So then that means that Harry's a slob.
That means that Harry is a slob. Well, more so that Harry's
Harry is
more.
more of a slob than Larry is.
So Harry might want to take a spare shirt.
Harry might need to take a shower.
And our last problem here, thank you Stella so much. If we were to order, wrong problem.
I kind of like how this went from me making fun of you just by calling out your name to everyone else. Like, us having this.
Oh, the less I can teach, the better. This year's just been really funky and it's weird to get you guys up here. We're doing class answer on this. Oh, I went to check when we're done with class and I did not do that. 48. All right. Who is least likely? Well, I don't even know what the question is, but these are the probabilities. So who here is the least likely? Class? Tina, because this is 5 hundredths, right? 5 hundredths, which would be 1/20th if we put it into a fraction. Who is next likeliest? Tony, because this would be 2. No, this would be 10 hundredths, right? Like we just heard from Lacey, we can just put an extra 0 on if we want to. And then this is 85 hundredths, right? So that is going to be our most likely. Guys, thank you very much for an awesome class. Please make sure you have those day 1, 2, 3 worksheets tomorrow.
Please make sure we have
The worksheets from like days 1, days 2, days 3.
Oh, yeah, we have homework due tomorrow.
You have homework due today. You have homework probably due all the time. Because Mr. Hudson's a grand jerk.
I know.
He thinks that the only way to learn math is to practice it.
Yeah, that's so stupid. The only way to learn math is to do LA. So half the time you don't know the answers, that's why you're asking us?
I did not say that. But I also did not say that.
What if you do it if you get it wrong?
Play it off as a teachable moment.
Do you just like send the world, or like that generation into the world knowing that like they got it wrong?
I mean, we hope that somebody figures out that it's wrong. Whether it's me or somebody else. You know.
Hold up.
So on the days where you say I was wrong, does that mean you didn't know and you have the best answer, you said yes and then realized that's wrong?
Sometimes. Just make it up as you go, right? Fake it till you make it.